Hello and good morning. This is Mehak Rohara, your instructor, and welcome to the sessions where we would be discussing the chapter Refraction of Light at Curved Surfaces. Before this, you have studied about reflection of light at both plane surfaces and curved surfaces. And in the previous class, you have studied about refraction of light at plane surfaces. You know that reflection takes place when light travels in a straight line, it strikes a surface, it cannot penetrate that particular surface, so it bounces back in the opposite direction, and the angle of incidence, that is the angle the incident ray makes with the normal, is equal to the angle that the reflected ray makes with the normal. And you know that there are laws of reflection which are followed in both cases, when light travels in a straight line and strikes a plane surface, and when light travels in a straight line and strikes a curved surface. Laws of reflection are followed in both cases. Let me remind you about the laws. The first one was that angle of incidence is equal to the angle of reflection, and the second law says that the incident ray, the reflected ray, and the normal to the point of incidence, they all lie on the same plane. After you came across reflection, you came across another term which is associated with traveling of light, which was refraction. Then you studied that light could not only reflect but it could also penetrate surfaces such as water, and then when it did that, it used to bend, and there were certain reasons for that, and that is what we will go according to this in this particular chapter. I will remind you of your basic concepts of refraction of light at plane surfaces, and then we will continue to see if those particular laws of refraction that we study right now, are they followed for curved surfaces also, and are there any similarities. So let's begin by discussing what we would be doing in this particular session. So, in this session, we will first discuss what refraction is. I will remind you a little bit about the basic definitions of what you have studied about refraction. Then we will observe refraction in our daily life by observing a very simple experiment. Then we will get an overview of refraction at plane surfaces. That is how laws of refraction are followed in plane surfaces and how refraction takes place at plane surfaces. For this explanation, I will use a example for how light travels from air inside a transparent glass slab, and how it goes back from it. Then we will study laws of refraction. Then we will see how behavior of light is there in two different mediums, but that this time this medium will be curved and not plane. Then we will study 2 to 3 definitions that will be relating to the behavior of light which is incident on a curved surface, which is separating the two mediums, let it be air, water, air or glass, glass and water. And then we will make a summary of whatever we studied in this session. So basically this session is just a reminder of how we have to go back to what refraction is, and how we have to go back to recalling what our laws are and how we observe refraction in our daily life. So let's begin. Now, as you have studied in earlier classes also, you know that light travels with different speeds in different mediums. Yes, light does not, you know that light has a specific speed in vacuum, and we know that it is 3 into 10 to power 8 meters per second. But when light travels from air to water, or from water to air, or when light changes the medium it travels from, what happens is light's speed decreases or light's speed increases. And due to this reason, light actually bends. If you see in this diagram, light is coming in a certain direction, but as it passes the prism, it bends in a certain direction. When it is going away from the prism also, it is going to bend. Why? Because light's speed is changing. And hence we study this term which is termed as refraction of light. Change in the path of the light ray. As you see, this light ray was traveling in a certain path. It got obstructed by the prism, and since this light ray could penetrate that prism, it changed its direction and then started to travel in that direction. So basically, change in the path of light ray is as it passes from one medium to another is called refraction of light. Actually, refraction is a phenomenon that just does not take place with light waves, it also takes place with sound. So if you are describing refraction in terms of physics and not just refraction of light, you will say that refraction is defined as the change in direction of a wave which is passing from one medium to another, or from a gradual change in the medium. Refraction of light is the most commonly observed phenomenon. If you see, there are many mediums around us, or there are many substances around us that light can penetrate. And since light is going to penetrate that medium, the speed of light is going to increase or either decrease. And since the speed of light is either going to decrease or increase, what's going to happen is it's going to bend. And that's why we say that it's going to change its direction. Light also is a form of a wave. This is something that you will study in later classes. Right now you are studying straight line motion of light. In later classes you will study that light is actually a wave, and that is why we are describing light refraction as to be a change in direction of a wave which is passing from one medium to another. Let's go further. So, as I told you, when light travels and when it changes its medium, so when it's going from air to glass, or when it's going from air to water, or suppose it's going from water to glass, or it's going from glass to air, anywhere where light speed is changing, there we are going to say that it's going to bend. Now, there are rules for it. You know that air is a more free medium. There are free particles in air, while glass or water are more condensed medium. They are more denser mediums. They have their particles more close to each other. So we say when light travels from a rarer medium being air this time, to a denser medium like glass, it is going to bend towards the normal. The speed of light is going to decrease and it's going to bend towards the normal. If you see, this ray is the incident ray and it makes a certain angle of incidence with the normal. And then as soon as it penetrates the glass at the surface, it's going to bend, and it's going to bend towards the normal. So the angle of incidence is going to be greater than the angle of refraction. Now, as the light bends, it's going to travel, and now it's going to reach the surface of the glass again. So it has to go through refraction again at this point, because again the medium is changing. From here it's going to change from glass to air again. So this time light is traveling from a denser medium to a more rarer medium, to a more free medium. And this time light is going to bend away from the normal. So this time the angle of refraction is going to be smaller than the angle of emergence. So this is what refraction of light is trying to explain you. When light is traveling from different mediums, from one medium to another, light's speed is going to increase or decrease. And when light is traveling from a rarer to a denser medium, the speed is going to decrease, and hence it is going to bend towards the normal. If you see this light ray that is refracted inside the glass, it is closer to the normal. And when light ray travels from a denser medium, which is glass, to a rarer medium, which is air, then light is going to bend away from the normal. As if you see this ray, it is away from the normal, and hence we say that when light travels from a denser medium to a rarer medium, light is bending away from the normal, because now light was traveling at a slower speed. It came to the rarer medium, light's speed is going to increase again. So, observing refraction in your daily life. Most of you must have observed this activity out of curiosity, or maybe out of doing some kind of experiment. So, you take a glass which is half filled with water and you drop a pencil in that glass. And if you observe this image of this glass from any side profile, you will see that the image of the pencil is distorted. Till the point where you see the water surface, you see the image of the pencil in one direction, after which the half pencil from the water surface seems broken. This is a very common phenomenon of refraction of light. As light is traveling through air, it travels in a straight line. However, when light passes from one medium to the other medium, as you see, this is the point where it's going to now penetrate water. This is the surface. And refraction only takes place at the surface. Once light bends, it's going to start traveling in that direction only, in the direction in which it bent. So what is happening is light, when light is passing from this air medium to water medium, the path of light is bending, or we are saying that refraction is taking place at this boundary. And then refraction occurs only at the boundary. Once the light has crossed the boundary between the two medium, it will continue to travel in that different path in a straight line. Only now the direction of this light was different than the former medium. Here it was traveling in a certain direction, it bent, and now it is traveling in a certain direction. This is the reason why distortion occurs. The visual distortion actually occurs if you look at the pencil submerged in a glass half filled with water. As you see through the side profile of this glass, light travels directly from the pencil to your eye, and since this light does not change the medium, it will not refract. And once you see this entire thing from the sidelines, you will see the refraction also, and hence when your eyes are witnessing these both images at the same time, or this both refraction and reflection at the same time, a certain distortion is being caused. So the glass is so thin, and because the light starts and it finishes in air, it means that once light is traveling, it travels to the surface of the water, it goes down, it strikes the glass surface, it gets reflected back to your eye, and your eye forms an image. And as you see at the portion where the pencil was submerged in water, light travels from water to air, or you can say from water to glass to air. The light ray changes its medium and subsequently undergoes refraction. As a result, you will see that the image will appear to be broken, because half that part of the light which is submerged in water, it will appear to be wider than the part which is not submerged in water. And this visual distortion, this, you see that the pencil appears to be broken. This particular phenomenon or this event, it is caused by refraction or bending of light. This is how you can see refraction in daily life. Even if you see a coin that has fallen down on a surface which is covered with water, you are actually seeing the refracted rays, which are then being reflected back to your eye. Now, let's overview what we have studied in our previous classes: refraction through plane surfaces. So, this is a glass slab A, B, C and D. It is purely transparent, so light can penetrate through it, and we have two medium. Let's say if this is one medium, air, and this is one medium, which is glass. So light is going to be incident on the surface of this glass slab. So it's going to be incident on the line segment AB. As I told you, refraction only takes place at the surface. Once light bends at that surface, light is going to travel in that changed direction. So there is this incident ray, let's say that is SP. The incident ray is now incident on the slab side AB on point P. This is the point P. And you have the normal. So we have the angle of incidence marked, and this incident ray is now going to bend towards the normal, because glass is a denser medium than air, and hence the speed of light is going to decrease. Speed of light is going to decrease, and the ray of light is going to bend towards the normal. So the angle of incidence here is going to be larger than the angle of refraction here. Once it starts to bend, it bends and it starts to move in that same path. Now it's moving on the same path, and now at the slab CD, it is time for the light to change its medium again. So it's going to cross from the glass medium to the air medium. So refraction is going to take place again. But this time refraction is taking place from this medium, which is glass ABCD, to air. So this time it is going to travel from a denser medium to a rarer medium, opposite of what happened here at AB. So here the denser medium, which is our glass, here light ray is traveling this ray, and now it is going to go under refraction again. So as it goes under refraction, you have seen this normal, it's going to bend away from this normal. So here again the angle of refraction is going to be smaller than the angle of emergence. The angle that the ray makes when it refracts back the second time, or it emerges from the glass slab, this light ray is called emergent ray. Why? Because it is emerging from the glass slab. So this is the normal and this is the emergent ray, and E is the angle that the emergent ray makes with the normal. One thing you will notice is that this incident ray and this emergent ray are parallel to each other. So the light ray was traveling in a certain direction. It underwent refraction, and after refraction the ray emerged from the glass slab and it started to travel in the same direction. If you take this ray and if you place it here, you will see that this incident ray and this emergent ray, both of them will be parallel to each other. So refraction here is taking place twice. First when the ray is entering the glass slab, and second when the ray is leaving the glass slab. This is refraction through plane surfaces. And as I have already told you what the cause of refraction is, the speed of light is what differs in different medium. The speed of light in air is different than the speed of light in glass, and it is different. The speed of light is different in water, speed of light is different in oil. Speed of light differs from medium to medium. So the speed of light is less in a denser medium, while the speed of light is more in a rarer medium. And when the speed of light increases, it tends to bend away from the normal. So if you see, when the glass slab, the second refraction was taking place at point Q, it was traveling from a denser medium to a rarer medium. So now speed of light is going to increase, and since it increases, it bends away from the normal. And when it decreases, that is our first case when light was traveling from air to glass, it was traveling from a rarer medium to a denser medium, speed of light was decreasing, it was slowing down, and hence this ray of light will bend towards the normal, making an angle of refraction R. So I is angle of incidence, R is angle of refraction, and E is angle of emergence. So we know that even rays of light that undergo refraction follow some rules, and that is what we are going to discuss again, something that you have already studied in your previous classes when you have studied laws of refraction at plane surfaces. We know that refraction of light occurs according to the two following laws. The first one, incident ray, refracted ray, and normal to the interface of two media. At the point of incidence, they all lie on the same plane. Let's look at this law. The incident ray, this is the refracted ray, and the normal. At the point of incidence P, they are all lying on the slab AB, and hence they all lie on the same plane. Next rule, the ratio of sine of angle, sine is a trigonometric ratio. So the sine of angle of incidence, that is sine I, to the sine of angle of refraction, that is sine R, for a light for a given color. It means it's going to differ for red light, it's going to differ for blue light, it's going to differ, this ratio is going to differ for white light, it's going to differ for purple light. You know that light can split into 7 colors also when it passes through a prism. So light is actually not just white, it is available of different colors, and each color of light will have a different ratio of sine of angle of incidence to sine of angle of refraction. And this is constant, and this constant is actually the ratio of the refractive indices of those two media. So actually we say that the Snell's law of refraction can be represented as, if let's say N1 is this refractive index of the first medium and N2 is the refractive index of the second medium, then you can say N1 times sine of angle of incidence equal to N2 times sine of angle of refraction. or sine of angle of incidence by sine of angle of refraction is equal to n1 by n2. And this n1 by n2, which is the ratio of refractive indices of those two medium, is a constant. And this constant actually is the ratio of those refractive indices. This second law is called Snell's law of refraction. This is something that you have already studied in your previous classes when you studied laws of refraction for plane surfaces. We just have to see if these laws of refraction are also valid for curved surfaces. So right now what we have discussed is that laws of refraction are followed at plane surfaces because we have only seen how light is behaving when the point at which the incident ray is bending is a plane surface. Now we have to see how behavior of light takes place in two different medium again, but this time they are separated by a curved surface. So the surface at which the light is going to be incident, it's not going to be a plane surface, it's going to be a curved surface. For example, let's say the brim of the glass, it's a curved surface. So if you see a horizontal light ray that is coming from the air, it's going to touch the glass, it's going to penetrate the glass, and then it's going to go inside water. So this is two different media, right? Air is a different medium, glass is a different medium, and water is a different medium. So you can see the setup that is shown here. This is air, this is a curved surface, and this is water. This curved surface could be glass at this moment, or you could take any other curved surface. We just have to see how light reacts or how light penetrates another medium when the point or the plane at which the incident is going to take place is not straight line, it is a curved surface. So you have light rays that are coming to a certain curved surface, and then you see right now all of them are parallel to your principal axis. You have already studied in reflection of light at curved surfaces what principal axis is, what center of curvature is, what radius of curvature is, what focal length is, what focus is. But I'm going to remind all of these terms to you even in this chapter because they are very important when we will come to image formation. So if you consider a curved surface that is separating the two media here as it is shown in your figure, the center of this sphere, so this curved surface must be a part of something, right? So if you usually see that the curved surfaces, we say that they are part of a certain sphere or they are cut off from certain spheres. So whatever the center of that sphere will also be the center of this cut off surface, and that center is the center of curvature for this particular curved surface also. Need I remind you, this is not a reflective surface. Here the light is going to penetrate this surface. This is not a reflective surface which is polished from one side and darkened from one side. Here light ray is going to come and it's going to penetrate this surface, it's going to change its medium and it's going to bend. Now the center of curvature is being denoted by letter C. Another point any line that is drawn from the center of curvature to a point on the curved surface becomes normal to the curved surface. So any line that is passing through your center of curvature to the perimeter of the sphere or any point on the surface of this sphere, this line will act as normal. So actually on a curved surface you can draw many normals because you can have many lines that will pass through the center of the sphere. So all these lines are going to act as normals. Even this principal axis where it is joining the pole and the center of curvature, this is also going to act as one of the normals. One of the normals, not the only normals. So when light ray, you see that it is traveling in a straight line, if it is parallel to your principal axis, it's going to bend in the direction of the normal, and it's going to go and it is going to cross and it is going to meet at a certain point. What that point is going to be, we are going to discuss later. But right now you only see that light rays are incident on this curved surface, and we are only trying to identify how many normals we can draw. So any dotted line that passes through the surface of this center the surface of the sphere and it can join the center, you see that this line is going to act as normal. This line is also going to act as normal. This line is also going to act as a normal, while this line is also going to act as a normal. So any line drawn from the center of curvature to a point on the curved surface will become the normal. And this was also seen in when we were discussing reflection of light. So these things have not changed. These are the similarities here. Let us study some definitions that are relating to light that is incident on curved surface, which is separating two different medium. So let's say this is your curved surface and here is one different medium and here is one different medium. This is your sphere, imaginary sphere, which is completing your circle. This is another medium. So here speed of light is going to be different and here speed of light is going to be different. So the center of the sphere of which this curved surface is a part of is the center of curvature, and you know that it is denoted by letter C. Here also in this chapter we are going to use same notations, and it is here also it is going to be denoted by the letter C. Principal axis is going to be the line that joins the center of curvature to the pole. If you say this point where the laser pointer is pointing at, if this is point P, which is dividing your curved surface into two equal halves, this is the pole and this is the center of curvature. And this straight line that will join both of them is going to be the principal axis. Radius of curvature. The radius of curvature of the sphere of the curved surface will be again the radius of that same sphere of which that curved surface was a part of. So if this was the sphere and then this is the radius of curvature of the sphere, then this is also the radius of curvature of the curved surface. This is also going to be the radius of the curved surface which was cut off from this imaginary sphere. So these are some definitions which are similar to what we have studied in our previous sessions or what we have studied in reflection. So I hope you remember them, because these are going to be important definitions when we come across lenses or when we come across image formation by two different curved surfaces and they're going to be joined. This is all going to be something that we are going to study in the coming sessions. Next. So this is all for this session, reminding you what laws of refraction were, reminding you how you see refraction in your daily life, reminding you and giving you a little bit of introduction of how we are going to go about studying how light rays are going to behave in curved surfaces. From here, everything that we study is going to be dedicated to refraction at curved surfaces. I hope the basics of what refraction of light was at plane surfaces and how you observe your refraction in daily life has been clear. Let's make a summary of what we studied in this session. We said that change in the path of light ray as it passes from one medium to another medium is called refraction of light. You can say refraction is the change in direction of a wave which is passing from one medium to the another, or you can say it takes place as a gradual change. So light is passing, and after a certain time you will see that it will go from one medium to another medium. Refraction takes place in sound waves also, and light waves also, and other waves also. Refraction of light is the phenomenon which is most commonly observed. When light travels from rarer to denser medium, it's going to bend towards the normal. When it travels from denser to rarer medium, it is going to bend away from the normal. It is because the speed of light is different in different media. Speed of light less in denser medium and it is more in rarer medium. When the speed of light reduces, it tends to bend towards the normal because it is going towards a denser medium. When speed of light increases, it tends to bend away from the normal. Why? Because the speed of light is increasing. Particularly, we represent I as the angle of incidence, R as the angle of refraction, and small e represents the angle of emergence, because once a light enters a certain medium, we also show that light emerges in the opposite direction from that medium, and usually refraction takes place twice. Now, refraction of light occurs according to the following laws: the incident ray, refracted ray, and normal to the interface of two media at point of incidence all lie in the same plane. This law is also followed for curved surfaces. The ratio of sine of angle of incidence to the sine of angle of refraction, that is sine I by sine R, is a constant, and this constant is equal to the ratio of the refractive indexes of both of those medium, and this is a constant. This is termed as Snell's law, which is also followed for curved surfaces. So refraction of light, which occurs in the for plane surfaces, occurs according to these two following laws, and these two laws are also followed for curved surfaces. So in the next coming session, we would be studying about ray diagrams of how light is going to behave with two different media. Right now we studied in reflection of light at curved surfaces when we were dealing with concave and convex mirrors. We were drawing behavior of certain light rays that would help us draw diagrams later, or the light rays whose interactions we already knew. So the same case is going to happen for curved surfaces when refraction is also taking place. We are going to see some light rays which have special behavior, and those light rays, when are refracted, they will go in a certain direction, and we will be able to know those directions, and using those light rays we will be able to form images. And hence the next thing that's going to come is the derivation of that curved surface formula. How are you going to relate the image distance, the object distance, the focal length with the refractive indexes of those mediums? How are you going to do that? That is the derivation of a curved surface formula. Then from curved surfaces we are going to come to objects that are lenses, that are used in our daily life for a lot of purposes, and hence we are going to say how lenses behave with the certain light rays, how refraction takes place with lenses, and how images formed by convex lenses, concave lenses, and what are the uses. And then we will make a summary of what